Hey you guys, in this video we're gonna continue creating our Q class, and we will continue by going about creating our overloaded operators. So let's see what we have so far. So in the Q class, in the first video we covered our constructors, and here we have our unparameterized constructor, our parameterized constructor, and our copy constructor. We also went about in creating our destructor. And then we have three getters, one for the size, one for the beginning of our data or the front of our data, and the other for the back of our data. And that was the first video. In the second video, we made our enqueue method to add data to our queue. We made our dequeue method to remove data from our queue, and then we have print, empty, and search to determine, certain states of our queue. First, to print the contents of our queue to check if our queue is empty or not, and then to search for a particular value inside of our queue. So now, what is left? Well, let's start with our overloaded operators. So I'm gonna return a stack here of data type Q, the same data type that we've created, and we'll go about declaring the operator. Operator equals, oh man, there we go. So if it turns out that our input queue is empty, we're going to delete our internal data, and then we are going to make our queue empty. So first I'll check if our size is equal to 1. If it is, I'm going to delete the data as if it's just one dynamically allocated variable. Otherwise, we got to do the deletion as if it is an array of data. Then when this is done, we're going to make our queue empty, so we'll set size equal to 0. We'll point data to our null pointer, and then we're going to return this. Once that's done, we're done with the case that the queue that we're going to be assigning to our current queue is empty. Otherwise, we're going to check if our queue has a size of 1. If it is, we're going to take a copy of that data. So we'll have queue, and this is going to be a particular queue value, and that'll be equal to the dereference of queue.data. I do this because, again, to access the first element of a dynamically allocated array, because the array is like stored through a pointer and accessed through a pointer. If I dereference its original address, it's like saying data of 0 in terms of indexing. So then I gotta go about deleting my internal data, so we'll check if size is equal to 1, and honestly I'm just gonna copy this. I should have really made this into like a private function, maybe like clear internal data or something, just to make things a bit easier. Otherwise, once we have that done, we're gonna reallocate a new queue with the value of our queue value, and then our size will be equal to 1, and we will return this. Actually, no, I'm doing an else statement here. Way at the bottom, I'm going to return this. Then we have our else statement. And this is the case where we're going to be considering that, well, shoot, now the internal data that we're going to be copying is going to be part of, well, a more involved array. So I'll have queue size, which will be equal to our queue.size. Then I'll allocate some temporary data. So I'll have queue data copy, and that'll be a new queue with the size of queue size. We'll declare our iterator similar to how we did with the stack, and then we're going to copy the contents of the queue that we're going to be assigning to our internal queue to our temporary holder of data, which is going to be a queue data copy. So I'll initialize my for loop here, and then I'll copy the contents of the input queue's data to our queue data copy. Once that data is copied over, you guessed it, I need to get rid of my internal data, and here's how I go about doing it. Once I have this done, I'm going to reallocate the data. So I'm going to say data is equal to new queue of our size, queue size, and then I'm going to have my for loop, which I'll just copy this, where I'll copy my internal data from data copy. So I'll change this, make this data copy, and then, oh man, I need to dereference this. Actually, I think I didn't do that here. Yeah, I need to dereference it. Ooh, that would have caused an error that I would have not have wanted. Now that that's done, what we're going to do is, oh man, let me get my cursor down. Then we need to redefine our size. So our size is going to be equal to queue size, because now we've just copied everything from queue over, And then we need to delete our Q copy, our Q data copy, not our Q copy. And that should be end of that else statement. And once that's done, again, we return this at the end of everything. Because when we're copying our queue, we need to consider 3 cases: when the queue is empty, when there's just a singular value in our queue, and when there's more than one value in our queue. And we've covered that all here. We copy the data or initialize it to null, and then once that's done, we return this, and that will be the end of that operator. Ooh, I almost forgot to not return the internal class itself. So now where does this leave us? Well, this leaves us with our friend functions, similar to the stack. I'm actually going to flip the order. So when I did the friend declarations for the stack, I only declared the double angle brackets operator for printing cout. I implemented the double equals, and I just declared the not equals. Here I'm going to do the reverse, where I'm going to be implementing the double angle brackets operator, just declaring the double equals operator, and implementing the not equals operator. So let's get started with that. So because of that, I'm going to have my template and type name. So I can't use Q now. Let's default to T. That's like the one that many people use. So let's use that. Typically when you go and you do generic programming like we are here, you'll find that people use T a lot, for T for template. Just so that way it's consistent with what other people use and we can all kind of understand each other. Now we're going to use this as our input. Like our array here, I'm actually going to copy this. We're going to iterate through the entirety of our queue. So I'm going to be replace that with a dot, and we're going to be accessing our size, and we'll use out, print the internal data, and then separate it with the space. After that, we're going to return out. So, if I remember correctly, this is exactly how it's done for our stack. So then now we're going to redeclare our template, which I'll just copy here, because who wants to write that kind of code? Minimize code writing. So we'll have our operator, double equals. We'll have our const qt a, and const qt of b, and we're just declaring it here. And so next, for our not equals, I'm actually just going to copy everything, replace this with the not equals, go right here, and I'm going to assume that we're going to have our double equals operator implemented, and just call that. And what I'm trying to get here is that when you declare these friend functions, and I need to precede these with friend. The thing about these friend functions is that you have the option of just declaring it or implementing it right as is. And whether or not you want to just declare them or implement them in the class, I guess is up to you. My kind of rule of thumb is that if you only have a few, I would say, I don't know, I'm putting an arbitrary cap, maybe like 5 or less operators, or if the operators are not too involved, maybe just keep them in a declaration of your class. But maybe if you're overloading, like, I don't know, if you have like a bunch of friend functions, maybe you got like 8 or 9 of these friend functions that you're doing like operator overloads with, or just friend functions in general, I would declare them here and implement them right under the class. Now, speaking of implementing friend functions under the class, we should probably do that now. And I need to get rid of friend. So our double equals should be actually pretty much the same as it was in the stack. We want to do the same thing. So we need to iterate through here, and we're going to be checking if at any point a underscore data plus whatever index we're using is not equal to b underscore data plus I. We're going to be returning false. After all this is done, we're going to return true. And I forgot one of the most important things, that if they're not the same size, then it's not even worth comparing them because they're not the same. And what am I doing? That should be, you could use A size, but I'm actually going to use B size. Just because in the stacks I use A size and I can use B size. And it doesn't matter which you use, just as long as you use one of them, because, again, if they're passing the safeguard of this if statement, that means that they're equal and that they're comparable. So it doesn't, if the A size and B size are the same, it doesn't matter which one you use. And that should do it for implementation of our Q class. And again, I don't recommend you using this. If you do have to recreate your own queue or stack class for whatever reason, you use this theory that you know, and here's just an application of that theory. If I were myself implementing my own stack class, I would actually put a lot more work into this. I would add a lot more methods to use. And of course, as I'm using the data structure, if I need to override or overload any operators or add any additional methods or add any additional constructors, I do that. Just because I'm writing it the first time doesn't mean it's always going to stay like this. But anyways, in the next video, we're going to talk about testing our Q class to see if it works, and we'll crush any bugs that we find along the way. Take care, and I'll see you in the next video.